All right, last video. Now we're going to look at face detection and how to implement that. OpenCV has some cool built-in face detection modules, but this is, and so you can explore that. One thing we're going to look at is more slightly more general approach. This is what a lot of different algorithms are based on. A lot of face algorithms in hardware implement this type of thing. Basically what's called a cascade classifier training. So like using a trainer that is a cascade trainer, training a model that is trained on a series of small, simple features to define and classify what an image looks like. And by features, they mean things like this. So they take the simplest things and see how the image or image patches sort of activate when you apply this type of kernel to it. And then you say this is what a face looks like in the presence of these features, and then it prunes out noise and learns a model based on which features are more effective at determining what a face is. And so then once you know the model, that's sort of an offline process, and then once you know the model, you can load it in and very quickly just use those models to determine where a face is in an image using some simplified features. So let's go through how we might implement this in our OpenCV module to find a face in our image. Okay. So we'll go back here. Let's comment this background subtraction out. Okay, so we are going to need up here, we're going to need a face cascade classifier. So we can say cascade classifier. Let's call this face cascade because we're going to use it to find faces. Okay, and we're going to load in the face one. So face cascade dot load. It's called har cascade frontal face default dot xml. Okay. Okay, there. Just to double check that I have it here, I have it. It's in my directory here, so make sure you have that XML document. This is just, you can find different cascades that are already pre-trained. These are pre-trained models for different features, and so you can have a pre-trained model to find people, to find pedestrians, etc. And so this is just the one that we're using to find faces, and there's more accurate ones out there, and you can train your own if you want to, but that's a different video. Okay, so now we need to use this. So let's do okay, so we are going to need to have we're going to do some similar things that we always do here. We are going to need to do very similar things to here. So we are going to need a grayscale image. Okay, cool. Source gray, frame clone. Okay, so we are going to have a grayscale image. Now we are going to equalize the histogram in that grayscale image, right? So source gray, and we are going to put it in itself. So luckily, sometimes you can do this in place because it works on a pixel level, and so you can do it in place. So equalize hist, we do it in place. That's going to equalize the histogram and luminance values just to give some better stability. Okay, so now we are going to say we need a bunch of faces, rectangles. A list of faces are what are going to be the result of the cascade classifier. Okay, let's call our face cascade detect multiscale, pass in our input image, our output faces list, give it some values, default values 1.1, 4, minimum neighbors, okay. Cool, so that right there should detect faces. So after this, we can assume that we're going to have a list of faces. And so let's draw something where our faces. So for each, for size ti equals 0, I less than faces dot size I plus. Okay, so for each face, let's just draw an ellipse, right? Let's get a center point from the face itself. So faces I dot x plus width of the window, faces I dot width over 2. Okay, because we want the center to be the center of where we found it because it's in the corner. So the x and y value that comes back is the corner of where it found the face. It gives us the width and height of the face as well. So let's just move that to the middle. Faces I dot height over 2 plus faces I dot y. Okay. Faces I dot height. Okay. Cool. So that's our x and y value for our center point. And we can draw a circle or an ellipse in our image at the center location. Size of the ellipse is going to be faces I dot width over 2, faces I dot height over 2, thickness, ellipse 0. This is going to be a different one. Start angle, start angle, end angle. So 0, 0, 360, scalar, 255, 0, 255, just the color, 4, so it's thicker. Cool. All right, so this should draw, this should detect and draw, yeah, so this should detect, okay, this should detect faces in our grayscale image, and then we should draw the center of the faces that are detected, if it does more than one, in as an ellipse centered around the middle of the face that it found in our image. See if it compiles. Sure enough, it compiles, yay, and let's run it and see. Oh, it's kind of weird. Why does it do that? Well, for some reason only draw, I guess it only goes to there for some reason. Okay, well, it finds my face. Notice it's pretty slow. I'm doing it on the full frame image. You should probably do this on a reduced size image to get better performance, and also run it in release mode, which will let you get real time. But that's the idea. It's pretty good. I don't know why it's not a full circle. Oh, because they said 260. Look at that. Not 360. Typo. So it draws an ellipse like that. Okay, and notice how it gives me a width and a height, right? So it gets bigger and smaller as I get closer as well. So that's pretty cool. It's not perfect, but it works. Not bad for free. Pretty cool. Anyway, so I hope that you guys can try that and get that working, because that's pretty fun. All right, thanks. See you later.